Hello, everyone, and welcome to ICCI 2025. It's a pleasure to be here to discuss a critical shift in how we approach industrial AI. The journey from a promising prototype developed in a lab to a reliable, scalable, and high-performing model running live on the factory floor or in a critical infrastructure is fraught with unique challenges, especially when dealing with the real-time data and production-grade reliability. Today, we are going to dive deep into this transformation with our talk from prototype to production, mastering real-time AI deployment in industrial environments. We'll specifically examine this challenge through the lens of crucial public service, exploring a case study on industrial MLOps for water demand forecasting in Greater Sydney region, where the stakes are incredibly high and the need for accurate and timely prediction is paramount for our resource management and system resilience. So, as we all understand that translational research or applied ML is a bit different than what we study in the books. So the first step is to understand who is the business owner, what the business do, and what is their target and what they want to achieve. So first of all, I would like to provide you a brief introduction about Sydney Water, which actually provide and provide water to the Greater Sydney region. So let's have a brief look at what Sydney Water do.
When the audio is not.
Sorry? Sorry? So you couldn't hear the audio? Can you hear me?
Ma'am, we can't hear this audio on this what you're displaying.
Okay, just give me a moment. Oh, so we'll replay this video. This video will provide you a brief understanding just in under 1 minute what Sydney Water is and what's the role of Sydney Water in Greater Sydney region. Let's have a look at it again. I'm sorry for this trouble.
Good day. Ever wondered how Sydney keeps the water flowing? Sydney Water ensures a sustainable water future for Greater Sydney. Droughts are a big challenge. The 2017 to 2020 drought was a game changer. Storage levels dropped by over 50% in just 2.5 years. The Greater Sydney Drought Response Plan has it covered. Sydney Water promotes water-efficient practices and recycling. Exploring purified recycled water could cover up to 25% of needs by 2056. Sydney Water ensures a sustainable water future for all of us. So, next time you turn on the tap, remember the hard work behind the scenes.
So this is a brief introduction of Sydney Water. As we get this idea from the video that Sydney Water is a utility company. It's the biggest utility water supply company in Sydney region. And I would say in the whole Australia. And they actually provide, water to the Greater Sydney region. Now, what happened in previous years, like a decade ago almost, there was a drought and there was a shortfall of water and they couldn't supply the water to the Greater Sydney region, which was really a tough thing and really not acceptable by people here in Australia. So they were actually trying to mitigate such happenings in the upcoming future. So they actually started to think about what is the business problem. So this is the step one where you pinpoint your clients' pain points and you target that and tell them that you can help them out in solving that. So once you identify your client, once you identify the pain points of those clients, it's important to understand how they operate, what is the business process, and how we can transform that business process without actually disturbing the legacy system. And of course, the human factor is the most important. And we make sure that we do not threaten the jobs of humans, and we do not replace people with AI. And because of that, human will be able to provide us the whole information that we need to create these AI-based data-driven intelligence system that can help us in decision support. One thing is very important to understand, that we must use AI as a decision support tool rather than making it a whole autonomous system. Because personally, I believe that whatever the scenario is, whatever the advancements are, I think the best AI-based algorithm is a human brain. That's it. So let's understand what was the problem, and let's see what were the operational areas of Sydney Water. So here you can see that the area of operation for Sydney Water is across these different sites where you can see the color coding. And these are the plant locations from where Sydney Water mainly provide water to the whole Greater Sydney region. Now, of course, when you have a couple of sites or more than that to provide a specific utility service, then there is a need to make sure that you don't spoil the whole system, and you need to select one specific site for the proof of concept, deployment and testing. So we selected the Liverpool site, one of these Sydney suburb, to run this project when we have reached the final deployment stage. Now, because we were at the beginning of this project and we are at the stage one of translational research, the challenge is that we need to understand what the problem is. And the heart of this research is very simple. And it's a very, important challenge. That is to map an AI-driven system onto a standard legacy system to manage a sustainable water supply without disturbing the existing process. This is really very important. And then again, you have to go for client interviews, and you have to talk about the KPI alignment, what they think would be a successful, I would say, system. And what our clients said, they said that our current energy storage solutions are never designed to meet the modern demands in mind. Now we are asking these systems to do more than ever what they were intended to do. So we must think how we can create a sustainable water supply from the ground up. Now the thinking has changed, the era has been shifted, but the legacy systems are old, and the infrastructure is so big that it can't be changed. So in the second step, when we are trying to model their problem, we have to understand their manual processes. So here is the process flow diagram that you can see on your screen. So what happens is every day, one of the plant operators comes, they look up their data set. That data set is composed of an Excel sheets, where at 7 a.m. they would have a look at what was the demand of the water in the previous day, how much water they have released to the reservoir in the past one day, based on every location. So we are talking about Liverpool in this scenario. And then they would use Sydney Water's proprietary formula to calculate that what would be the rough estimated water demand for that particular day. Now in Sydney, there is a sudden shift in temperatures all the day. Morning, it will be chilling. In the afternoon, it might be 35. By the time it's evening, it might be again 18 degree. So what the operators do, they actually go for looking at the temperature. They go for the Bureau of Meteorology data and see what would be the temperature throughout the day. And then based on if it's hot or cold, they would basically add on some value to the forecasted value, and then they will release that water to the reservoirs of a particular suburb. Now, they do the same process at 12 p.m. and 5 p.m. to make sure that they are actually providing the right amount of water the specific suburb requires. So this is their, all manual paper-based system, and the plant operator is the main decision power who has no help other than just the experience to decide what could be the real demand that is needed. Now, So what was the solution? We provided them an AI injection pathway for a sustainable future, and we provided them with two different sort of machine learning models. One could do the forecasting task and one could do the weather-based prediction task. So you need to basically analyze what is the system and how you can fulfill the requirement of the system. And in step two, then you have to design your framework that can actually map the actual legacy system so that you don't disturb the system, you don't disturb the processes, but at every point of that particular system, you are providing them data-driven support. So what happened is we started with the data sources identification. It is really crucial to understand what sort of data you have got, because our I would say I'm not talking about only in Pakistan, even in Western countries, most of the organizations are not AI ready. There are no sources of data which are there for AI to be trained on. So we rely on what is available at the ground zero, and then we start training our models. And with the time, we keep on monitoring how they are performing and we update the models. So at this point, when this is a very old legacy system with no information, so we relied on shape files from Bureau of Meteorology. We relied on their temperature data, their precipitation and evaporation data, again from the Bureau of Meteorology. And Sydney Water had just only a daily water supply information with that. So we did some high-level pre-processing. We converted those shape files, which were in polygons, into some lat-long values, and then we extracted the plant location-based weather data, and we combined them with the demand data on the previous basis and performed some feature engineering to find out what would be the most suitable features for our models. Now, this is really very important to understand that pre-processing in the industrial systems is not as similar as we study in the papers. Usually we talk about having outliers being removed, but in this scenario we did not remove the outliers because we wanted to make sure that what are the extreme demand cases, we model them in our prediction algorithms. Alongside with that, feature engineering is generally left for data scientist or the researcher. But in your real life project, please make sure that you consult the clients. Client engagement is really an important factor, and they would like their participation, and they do tell us what is available in the production, because sometimes you have got the training data, but the same data points are not available in the production environment. So we need to make sure that whatever we are training on our model are available in the production environment. So for that purpose, we need to engage our clients and provide them feedback. In real-time projects, it is really important to be very transparent with what we are doing, what we plan to do, and what would be the final output with our industrial clients. Now, when we have got our models ready, then we need to make sure how we are mapping it. So as we discussed that we have to go for multiple machine learning models to combine in a single framework to make sure that we are covering the whole points and whole decision points of the legacy system. So this is the same process flow diagram which we discussed earlier in this presentation. So this part of our process flow was covered by forecasting seasonal models, where we would have a 10-day plus forecast based on any special event. By special event, we mean that there might be some supporting event in a particular suburb, so we might need more water. There might be some special events, holidays, or things like that, or some specific leakage points that can actually result in an increased demand. So those are all covered in the seasonal forecast. So we, every day, whenever one of the plant operators would open up the dashboard, they would be able to see the 10 days forecast. And those operators don't need to have much experience to forecast what they want to have in the next couple of days. Now, because we want to incorporate this part of our process flow model as well, so we have used deep learning models to provide weather-based prediction. And in the end, we are assembling these results to make sure that we have all that information which we have gathered through this framework available for the decision support. So this is the dashboard that we have designed, and you can see that it is providing all the information that we have. So in the first place, we have to select for the plant location. In this example, we have got Liverpool selected because that's the proof of concept site. And then we have got some information about minimum and maximum expected value of demand. So we provide them what could be the, buffer value they can think of. Then we have got the seasonal and weather-based forecast. And within the same dashboard, of course, you can see that every detail which is available is there. Actual versus predicted demand, whatever the plant, whatever the average demand is for the last 3 days, how things are going, everything is available for the decision support system. And we have also displayed the cumulative usage of demand from all the Sydney Water sites. It is really very important to have that cumulative forecast as well, because Sydney Water actually gets data water from Water New South Wales. So it's important for everyday use that the operators can request this much megaliters of water for the Sydney region. So this is how we actually go for developing our machine learning model based on the legacy system, and we can map it and make reliable, scalable systems. Now, when we are talking about the accuracy, of course, we look at maximum accuracy that we usually calculate using matrices that we have got for regression, classification, or different sort of problems. But you have to run your real-time prototypes for a good 6 to 7 months and look at the accuracies of how they are performing. And that would define how well you have designed your forecasts. What is the real demand and what your models were forecasting, that would decide if you have designed that algorithm in such a way that it is reliable, it is real time, and it is accurate. So these are the results from different sites, namely Liverpool, 𝗥𝗲𝗹, Mopsa, Pymble, Hermitage, and Cascade Orchard Hills. We have run this framework for a good 6 to 8 months, and we have calculated these matrices. Now, it is really important to understand about the project risk in such projects. For example, client engagement is one. You need to keep clients engaged. You need to have understanding of data sets, and data set could be really volatile. In many cases, for example, in this project, because this was really a complex client-based project, Sydney Water has got their own internal clients. So we got for, almost, I would say, we took 1.5 years to get the final data set. So data sets could be quite volatile because somebody would say ABC is the required data. However, the other client would come and say, no, it's the XYZ. Then you have to think about the modeling, how you model, because of course there are a lot of models, but you need to sometimes go for simpler models for the deployment, because they are actually sometimes working as good as complex models, and they are, deployment is quite cheaper. So you need to think about that as well. And finally, the production. Now, with the software industry and AI being so much closely integrating these days, you need to know whether you are going to containerize your work, or you are going to use any sort of service provider. For example, in this project, we had our own private secure cloud, Vault Cloud, where we deployed this dashboard, and it has a very secure connection with Sydney Water. So all the data is there within Australia, and we are not using any public clouds like AWS. So again, based on the criticality of your project, you have to look around the production as well. So but of course, these are standard processes. And now we have Chris DM with us, which actually guides us to how we can go for implementation of data science project across different industries. So the first step, as we have explained, is the understanding of business. Then you have to go for data understanding. You have to go for data preparation, analysis, and then you have to go for presentation, visualization, which is very important, and evaluation. So these are basically 6 steps which we have to look at. And again, we have to see based on every use case, things are different, and we can always, ask our clients what they want, because eventually they are the users and we need to satisfy their requirements as well. So in this short discussion, we have navigated the complexities of deploying real-time AI, moving our focus from the initial data science experiments to the rigorous demands of production-ready systems. The journey actually is illustrated by our Greater Sydney demand forecasting case study, which underscores that success isn't just about building an accurate model, it's about establishing a robust industrial MLOps framework. Now, I'm happy to take any questions if there are any.